Welcome back to the introduction to Kismet. In this video, we are going to supplement our existing Kismet sequence by causing a 5-second countdown to occur before we turn off our light.
That's right, and while we have this countdown taking place, we're also going to echo out to the screen the countdown number itself, meaning we'll start at 5, then 4, then 3, and we want the player to see this information as we're approaching 0, in which we're going to turn out the light.
That's right, and the cool thing about setting this up is later on, when you're exploring on your own, you could use the exact same thing to cause a sound effect of like the announcer going 5, 4, 3, you know, all sorts of things you could do at the same time.
That's right, because we're going to do this in kind of a corny way. If you were designing something for true gameplay, we're going to be using a log sequence object to echo this information out. And it's not really something that's graphically snazzy, but let me tell you what, it is a very important sequence object to use when you're trying to debug one of your networks, because it is a way of getting information that's inside that network out to your screen. So we're just going to use it in this case. We're going to pretend like we're using it as something for our player, but in essence we're using it as a teaching aid for you guys to see how you can get debug information out.
That's right. Now you can see that I have deleted that extra trigger that we created at the end of the last video. I have also removed that extra Kismet sequence that I had started to create as well.
So we will be picking up right where we left off in the last video before demonstrating how to duplicate everything. So we're just building onto that network.
Now the first thing I want to do is, as soon as the user has used trigger 4, in my case it could be trigger 3 or trigger 0 on your end, it could be any number, we want to start off by sending that little piece of information to the screen, a sentence that says you have activated the timed light switch. We want that message to be sent to the player before the toggle actually takes place. So let's hold down Control and drag this little trigger, this trigger used event out of the way. I'm going to hold down Alt and click on my connection there to break this open. And let's right click and go to New Action, Miscellaneous, and this is where the log is hiding. And there you go. Now the purpose of a log is to send information out to the actual game's log, which is available in text form. You can actually close out and read that at some point if you want to.
But fortunately for us, it does give us a property that enables us to output this information to the screen, and this property is checked by default.
That's right. So let's go ahead and get this connected in. So we'll go from the use trigger event.
So the moment you use the trigger, we're now going to send a pulse over to log, and then automatically, after log does its thing, it's going to continue that pulse on over to toggle.
Now, let's create the message that we're going to send to the player.
That's right, because take a look at log. What are we logging out? We haven't actually given it a message to log out.
Right, and we don't have anything in here that we could actually use as a property to send in. We need to create a variable for this. And what type of variable? We'll use a string, which is just a series of alphanumeric characters. Let's right-click, go to New Variable, and we'll choose a string. And under the string value property, I will add you have, let me capitalize you, not that I'm picky or anything. You have,
as Zach is having a hard time typing, I'll just remind everybody that a variable, once again, is nothing more than just a data container. So Zach is now containing this text inside of this variable.
Thank you for covering me while I get a spell checker
I've got your back, no problem.
Okay, now we have another problem. If we take a look at our log, you'll notice it's looking for a target pink or magenta variable, which, as we already know, is an object variable. We don't have a place to plug in a string variable. It's there, it's just hidden. To access it, we need to right-click on our log, and we have expose variable, and you'll see string in here, and boom, there you go. So you can just drag a wire right into your string variable.
And if you're just kind of digging along with some of these nodes and you'd like to see everything that is available, you can expose all of these things. You want to do that real quick, Zach?
You've got the show all
just going to do it from the log itself.
Well, you can do it individually here. So if you right-click on the log, you can say show all connectors.
Yeah, that's all I want to show for the time being, just so that you guys can see that we can log a string, a float, a bool, an object, target, int. It's all there. But what's really nice, because as you can see, this thing now looks, well, like some sort of square-toothed saw or something.
Kind of bloated.
Yeah, we can shrink it back up nice and fast by coming in here and hiding all unused connectors.
There we go.
How convenient.
So now it's nice and cleaned up. And you can do this on a global level with these two buttons here. You have hide unused connectors and you have show all connectors. Just be careful. It's going to do that for everybody.
Yeah, it's going to show lots of stuff. Now, you'll see the log is properly set up. It's ready to log that message that Zach has input into that string connector.
Go ahead and give it a shot real quick.
We sure can.
Close out Kismet. Let's fire off the level. And if we walk over and use the trigger, boom, you have activated the timed light switch. So every time we hit the key, we get that message.
So now you guys can see what we were talking about a minute ago when we said it's not really something graphically snazzy that you'd want to use in gameplay, but it is very helpful when you're wanting to get some debug information out of your network.
And in this case, it makes a great teaching aid. Now, if we pop back into Kismet, the next thing we want to do is create our 5-second countdown. Now,
better yet, even before we do that, how about this? We know that the next overall goal is the light needs to toggle off in 5 seconds.
Sure.
So we're going to tell them, hey, you've just hit the active-deactive Santa Claus switch, whatever we typed in there. I was talking when you typed it in.
Right.
But anyways, I'll put that message, then 5 seconds later, we want the light to toggle off. Okay? So how do we make this thing wait for 5 seconds to delay for 5 seconds before we hit that toggle?
We have two ways to go about causing delays in a Kismet sequence.
Okay.
There is the node-based approach, or the sequence object that is actually constructed for delays. It's actually a delay action.
Okay.
Or you can create your own custom delays on your connections themselves.
Well, let's take a look at the actual node first.
All right, let me start off by giving us a little more room.
You're always going to be looking for more room while creating networks.
Especially at 1024 resolution.
That's a fact.
Right-click and we'll go to New Action, and back underneath Miscellaneous, you'll see the Delay action, which I'll create, and we'll go ahead and break this wire to get that out of our way.
Interesting. So it has the ability to have a pulse sent to it to start it, to stop it, to pause it.
And then you have outputs based on finished or aborted.
Very nice.
Now, this is very handy. Like, let's say you want a 5-second delay before a door opens, but somebody could go up and push the button again, and that'll stop the actual countdown.
Okay.
Or maybe, like a 10 seconds before a rocket launches, but you want to be able to come in and abort that.
Okay.
So if it's aborted, maybe a red light goes off. You have
self-destruct sequence, and when it gets to the end, the finish is going to destroy all players.
There you go. You have that kind of power through this node. Now, if you use the non-node approach, which I'll show here in just a moment, you don't have any of this ability.
So let's hook this one up and see it work. I want 5 seconds, and then I want that light to toggle.
Let's go from out to start. We have no reason to want to stop or pause the countdown, so we'll leave these connections just kind of open.
But the ability is there.
That's right. We also don't really need to worry about it being aborted. We're just going to take finished and plug this into toggle. But now we need to worry about how long the duration of our delay is going to be.
That's right.
Now there's a property for this. If we select our delay, you'll see we actually have a duration property. We can hard code this to a value of 5, or if for some reason it's a number that needs to change as we play the game, we can right-click and create a new float variable. Notice it's dark blue, so it's looking for a float. And we can take this variable and set it to 5 as well. It's the exact same thing.
And for those that are new to working with data types, a float simply means that it's going to be a number with a decimal.
Right. Notice that even at 5, it's got 5.000.
That's right.
Okay, so let's give this a shot.
Okay, yeah.
So we'll close out Kismet, right-click, play from here.
Let's see how good our counting is.
Okay. 5,
1,
4, 3,
2, 1.
Okay.
I tried pausing it.
Yeah.
It's close enough. That's 5 seconds.
That was 5-second delay, and then our light goes off. We have a little bit of a problem in that we're not logging the information out, but let's go a step at a time.
Okay.
The next thing I'd like to do is show how you can create a delay without a node, so we'll go ahead and just nuke out our node. I'll make a direct connection from the log right over to the toggle, and on an input or an output, it doesn't matter which, you can right-click and go to Set Activate Delay. And this just gives you a number to add. So let's say 3 seconds. So we're going to delay this for 3 seconds, and I'm going to test this.
Now remember, real quick, basically going from output to input of something else, this is just the pulse we're sending to send activation to the next sequence object for it to do its thing. So in this case, we've said delay for 3 seconds before that pulse is sent over to the toggle.
That's right. It's not even going down the wire yet. It's going to sit right here for 3 seconds before it goes anywhere. So let's go ahead and close this. Right-click, play from here.
All right, I'll try to get better timing.
Okay.
Here we go. 3, 2, 1, click.
There you go. Excellent.
So I got my stopwatch now.
There you go. So nice. So we can come over here. Notice to the input, we could right-click and create an activate delay here as well. So let's set this to 2. So now we have a total of 5. And let's close this, and we'll try this one more time just to show you that these can be combined. 5, 4, 3, 2, 1. Click. There you go.
So very nice.
Total of a 5-second delay there. Now, if you want to remove these, all you need to do is right-click, go back to Set Activate Delay, and set this to 0, and you'll notice it disappears.
These delays will really become important in creating complex networks that deal with timing.
Absolutely. And they'll save you a lot of hassle over having to create a node every single time you need a delay.
Now, this was all fine for giving ourselves that 5-second delay before the light was toggled off, but we didn't really follow the requirements that we set out for ourselves when designing this sequence. Basically, we need each second that gets counted away to echo out a number for the player to see. 5, 4, 3, so on and so forth. And we're not doing that. Right now, we've just kind of held things up inside our sequence here until we reach 0, and then we hit that toggle. So we need to take a different approach in order to have a number logged out to the screen so that the player sees the countdown take place.
That's right. And we're going to show you how to do this by building a node system that actually counts down, and at each time it counts, every time the number changes, it's going to log the value of the number out to the screen.
That's right. Now, we're going to show you how to do this in a couple of different ways.
Right.
The first way we're going to show you, we're going to break that into 2 ways. We're going to show you a very long way, though we're not going to follow it all the way through because it is very long. And then we're going to simplify that into something that's a lot more logical. And then we're going to shift gears after showing you that approach and show you an even cleaner approach, just so that you have a good understanding of what is happening and why it is happening.
We really want to drive home the purpose of data flow.
That's right.
Okay, so let's begin with what we need to construct. What do we know about creating a countdown sequence? Well, the answer is not much. We know that it's going to need to start at 5, and then it's go down to 4 and 3 and 2. These are integer values.
That's right. We also know that, well, go ahead. Let's put an integer down. I see where you're going with this.
Okay, so let's go to new variable, create a new int. There we go. And we're going to set the value of this int to 5.
So now we have a container holding the number 5. Excellent. Now, we need this toggle to occur when this 5 is no longer at 5 but at 0, because the condition that we're looking for is a number that starts at 5 and counts all the way down to 0. And for a computer needs to be smart enough to know how to count. I mean, believe it or not, a computer doesn't really know how to count.
Right.
We need to instruct it how to. So what we're going to do is we're going to set up a very simple comparison system that says, take our number right here, which is 5, and compare it against 0, because that's what we're wanting to count down to. So is 5 equal to 0? No. So what do we do with 5? We need to make 5 one number smaller, 4. Then we need to ask again, is 4 equal to 0? Once again, no. What do? We subtract 1 away from 4. And so you'll notice that the number slowly approaches 0. And sooner or later, 5 seconds later, the number is equal to 0. So is 0 equal to 0? Yes. Excellent. Toggle the light.
And that's, I mean, if you want to really simplify that down and like into an analogy, we're going to make the computer go, can we turn the light off yet? No. Can we turn the light off yet? No. Can we turn the light off yet? Yes. Okay, turn the light off.
Basically, we're taking the kids on a trip.
So what I'm going to do is unplug our connection to our log, and we're going to create a comparison, like just exactly like Jason was saying a second ago. So let's right-click, go to New Condition, Comparison, and Compare Int. Ooh, kind of scary. We have an output, we have an input, so let's go ahead and fire this directly into the input. And now what are we doing? We have value A and value B. We're going to compare these two values together, and then a signal is going to be sent to one of these outputs, or one or more of these outputs, based on the result of that comparison. Now, what are we comparing? Value A is going to be this integer we've created here, this value which is currently 5. What are we going to compare with B? 0. We're going to say, is 5 equal to 0? No, it's not at first. What are we going to do? We're going to subtract 1 from it and then compare again.
And believe it or not, right now we're already set up for that, because if Zach goes ahead and clicks on this compare, take a look down in our properties pane. Value B is hard-coded to 0 by default.
Right. Now, just for readability's sake, I'm going to go ahead and right-click, create a new int variable, and leave this at 0 just so we can always see we're comparing to 0.
And this is a really good idea, especially if you're comparing it against a number other than 0, as opposed to going in and digging or setting a number inside your properties. Put the number out here so that you can see it, so that at a quick glance of the network, you can be, oh, yeah, that's right. I'm comparing 5 against 0. It makes a lot of sense.
Yeah, if you can read through your sequence with a cursory glance as opposed to just, selecting and digging through and figuring out what the properties were set to, you can save yourself a lot of time.
Now, basically, we've got our pulse coming in here, right? So, boom, pulse comes in. What happens? Well, is A, which is 5, less than or equal to B, which is 0? No, it's not. No signal, no pulse is sent out of this. Is A greater than B? 5 is indeed greater than 0, so we are going to send a pulse out of this. So where we send that information out of here, that pulse needs to trigger something that's going to cause this number to be decremented. That's very important because right now this number is just 5, and it doesn't need to stay 5 forever, because if it does, well, we'll get ourselves locked up in a situation where we'll never toggle our light.
That's right. Well, if you don't count down, you never make it to 0. The light will never go off.
Precisely.
All right, now what I'm going to do for just a moment is I'm going to take our toggle and our light. Let's draw a marquee selection box around the both of them, and I'm going to drag them down here out of the way. We're not worried about turning the light off yet. Right now, we're just worried about the countdown.
That's right. We've got work to do.
That's right. So if we find that A is greater than B, well, then we need to subtract 1 from our first value.
That's right.
So let's go ahead and right-click. We'll go to New Action, and we have some math actions in here. We're going to create a subtract int. And we're going to plug this in. So if A is greater than B, let's fire off this subtract int. Now, what are we subtracting? We're taking the value of this value A, which is our 5.
Actually, let me say it a little different.
Oh, sure.
What are we subtracting? We're subtracting B. In fact, let me grab the mouse here. We're subtracting B from A.
There you go.
So B needs to be a value of 1, and A needs to be that 5, because we just said a second ago that if A is greater than B over here in this comparison system, then what needs to happen is 1 needs to be subtracted from this guy. Well, this is basically A minus B equals result. Okay?
And the cool thing about visual scripting is that all we have to do to set this up is drag a single wire.
Ooh, how cool is that?
Now, we can take our subtract int, and we do have the option of setting value B to a value of 1. We can hard code it, or again, just for readability's sake, we can create a new int variable and set this to a value of 1 so that we can see immediately what we're doing.
And it is nice to go ahead and point out, Zach, that as you have just put in this variable hooked into that connector right there, that is going to override any value that you put in that property.
That's right. Anything plugged into these inputs out here will supersede any hard coding that you've done inside the properties of the node itself.
So this is awesome. We now have A, which is 5, B, which is 1. So we now have 5 minus 1, and the result is felt over on int result.
That's right. It's something kind of important to bring up. You'll notice a lot of these connectors we've had across the bottom up to this point have all been squares. When you see a square, that's an input. That's a number that you're feeding into the node. When you see a triangle, this is a number going out of the node that you are assigning back into a variable. So what are we doing? We're taking 5, subtracting 1, taking the result, and feeding it back into this variable. Feeding it into the variable. Remember, a variable is just a container. But we've now changed the value that's in the container.
That's right. But don't let this freak you out and make you think, oh no, but are we going to cause trouble with this and other people? No, we're not. Because remember, we're sending this pulse along, activating each of these sequence objects one at a time. So right now, this is the sequence object that is active. And this is the one that is taking 5 minus 1 and putting the result back over here. We're not affecting this guy. The moment we're actually done with this guy.
Exactly.
So we've left, our focus has shifted over to this guy.
Which is why it's so important that you understand data flow.
That's right.
Now from here, what do? You've subtracted 1. This guy now has a value of 4. This is still 0. We still need to compare these two together again. And then if A is still greater than B, we need to subtract 1 yet again.
That's right.
If you have never done any sort of scripting or coding before, your next impulse might be to create another int comparison. So which you absolutely could do. You could say, once you're done subtracting, I want you to compare these numbers again. How do you compare the numbers a second time? Well, simple. We've already seen how to do it. You just connect your wires up like so.
That's right, and by the time focus gets over into this sequence object, over to the right, that guy, we've already left the subtract int, and we know at this point in time, when we take a look at the variable all the way back over here, it contains a 4 now, not a 5.
That's right. We have subtracted 1 from it. So now we're comparing 4 against 0. Is 4 greater than 0? Yes, it is. So we need to subtract 1 again. Well, again, if you've never done any coding before, your next impulse might be to create another subtract int. Now, for the sake of speed, I'm going to hold down Control and select my subtract and int at the same time. Hit Control C, move over here, and we'll hit Control V, and we'll move this into position, just break a couple of wire connections. You'll notice that, fortunately, because of this, everything is already connected down here on the bottom.
Yeah, those A and B, they are connected to the right node.
So we can take A is greater than B, connect it in like so, and we're already starting our countdown sequence. We have 5. We're subtracting 1 to get 4. Comparing again, here's 4 being compared. Now we're subtracting 1 and getting 3. You would need another pair of these nodes, all of these nodes right here. We need to Control-C, Control-V again, and we could plug in. Now it's down to 2, and we could paste again, and now it's down to 1, but you can already see the problem. We have a very long sequence to do something that is very simple.
That's right.
What are we doing? We're doing the same operation over and over again a set number of times. you can do all of this with a single connection. As soon as focus leaves your subtract int, you can actually wrap it back around and run the comparison again. I'll connect it backwards. So what are we doing? We're taking 5, comparing it to 0. It's greater than. We're subtracting 1 to get 4, and then the output fires back into the compare int, now to compare 4 against 0. Then it'll compare 3 against 0, then 2, then 1. Then finally it's going to get down to 0, and something different happens. Suddenly, this connection is no longer getting a signal, because A is no longer greater than B. A is equal to B.
That's right.
And if A is equal to B, then A is equal to 0, and if A is equal to 0, we need to turn off the light. So we need to make this connection like so.
Now, we can test this out. But number one, we're not going to get any text put up on the screen showing us 5, 4, 3, 2, 1, 0.
Because we're not logging the number.
And number two, I bet you're going to see an instant flick of the light.
We won't even see it count down. That is because right now, this entire sequence we've created is calculated once every time the game ticks.
That's
every
right.
calculation. So if you're getting 60 frames a second, this is being calculated 60 times in every second.
That's right. 0.01666666667 times a second.
Yeah.
Well, I'm just saying, it's 60 frames a second. So let's go ahead and let's show them that if we jump in the game right now and use this trigger, it's going to instantly turn the lights off.
So let's walk over here.
And
Think.
click. Oh, bummer.
In fact, this is no change as far as the player's concerned to what we had a second ago.
The exception of we now have extra nodes in that the player doesn't know about.
Exactly. So let's pop back into Kismet. We can actually make this exactly what we need with a single delay.
Thank heavens we talked about delays.
Yeah, good, that's out of the way. So what I'm going to do is I'm going to come in here to my subtract int. Actually, you know what? That's where we're going to put it, but let me show you why we're going to put it there.
Well, you could put it in any place here. Think about it.
Yeah.
But
there's a reason that I've chosen this place.
That's
so
right.
We could come up with all sorts of different places. Like we could put a delay maybe right here.
Mm-hmm.
So let's right-click and go to Set Activate Delay, and we'll set this 1 second by default, which is great. And then let's test it out. So we hit it. Boom. Oh, we have nothing.
Well, actually, no, it's because we're not outputting words yet. No text.
Yeah, okay,
so they can't see that.
So you can't see it.
But you can explain it because this will make sense.
What we've got is we have the number 5, and then we are immediately decrementing that down to 4, and then we're delaying by a second.
Exactly. So it went purple.
That's right. So actually, the funny thing about doing this is you actually have a 4-second delay. We should be able to count it out. So it'd be 4, 3, 2, 1, boom. Oh, okay. It's off by a little bit because I can't count very well. But that's exactly what we have. We're immediately jumping down from 5 to 4. So what we need to do is kill that delay. We don't need that. That can just go away. So set that back to 0. We need a delay right here. So let's set an activate delay right before we do our subtraction. And the importance of this is we take our number 5, and then before we subtract, we wait 1 second.
That's right.
Then we set it down to 4. We compare again. Then we wait a second. Then set it down to 3. Compare. Then we wait a second. But the problem we have right now is we're not logging all this stuff out to the screen.
That's right. And we obviously need to get some sort of log set up that's going to send that number out.
So let's get this all set up. What I'm going to do is take my use trigger and my initial log. We're going to scoot these out of the way and break the connection because we want to log this out right before we do our comparison. So I'm going to right-click. Actually, let me show you another way to do the log. You can hold down the L key and left-click, and you'll automatically create one.
Very convenient.
There's a hotkey for it. So let's take out, plug it into the log. We'll take out here and plug this into our compare. Into the compare. All right, now, again, we need to bring in the right type of data. So let's right-click, expose variable, and I'll choose an int. And we'll take our int and just plug it in right here. We're taking whatever happens to be inside this variable, and we're going to log it out to the screen. I'm now going to right-click and go ahead and hide unused connectors just to clean that up a little bit. And then I'll move things around because we're so limited on screen space. I want you guys to see as much of this as you can.
Yeah, because right now, all right, so with all this cleanup, if Zach left things the way they were right now, what's going to happen is we're going to get you just activated the whatever switch, and then it's going to feed over, it's going to log out 5. But we're not going to see any other number logged out.
That's right, because look what happens when we run our loop. We get over here, we compare, is 5 greater than 0? No, we subtract 1. But then our signal only goes back to the compare, and we never hit this log again.
That's right.
So let's hold down Alt and disconnect our wire leading from the subtract back to the compare, and let's instead run it back to the log. So that what we're doing is we're logging the information, comparing, subtracting, and then logging our new result out as well. So let's give this a quick test. So let's right-click, play from here, and tick 5, 4, 3, 2, 1, 0. Boom.
And we might want a small delay right after it gives you that message.
Yeah, just to kind of humanize things a little bit, because usually you'll get a message, you'll have time to read it, and then the countdown will begin.
Yeah.
And I like the idea of the delay in between the message and the countdown being longer than a second, because that separates, that'll mentally separate the message from the countdown. So what we'll do is we'll grab, let me just make a little bit of room right here. We'll right-click on the output of our log, or you could do the input. Well, I wouldn't do the input of this log, because then it's going to keep hitting. Let's go right here. We'll right-click, go down to Set Activate Delay, and I'll do 1.3 seconds. So it's just not quite a second and a half, and we'll test that out. Of course, you'll want to test this sort of thing and see what feels right, maybe tweak a little bit on your own.
And so there was the delay. That looks much nicer.
2, 1, boom, and there we go. Now we have a couple of little issues. If we walk over and we try to use this again, you have activated the light switch. 0.
The lights just came right back on.
0. So there's not much of a timer anymore.
Well, what happened to the 5, 4, 3, 2, 1, 0?
Well, that's a good question. What did happen to it? It counted down to 0, and then it stays at 0.
Oh, yeah, that's right. There's nothing there to reset it back.
That's right. So that's what we need to do. Now, what I'm going to do is I'm going to take the very beginning of our sequence, and I'm going to verify that this number is set to 5. So as soon as we hit this switch, the very first thing we're going to do is say, hey, set this number to 5 just in case.
So it's not really so much of a verify it's at 5. We're just going to force set it to 5 always at the beginning, because that makes sense.
Sure.
Because right then we're triggering it. We are depending on it to always start off at 5.
All right, so I'm going to hold down Alt, and we'll break this connection. I'll right-click and go to New Action, Set Variable, and we have an int. So we're setting an integer variable. Let's go ahead and get this connected for data flow from our trigger to the input, from the output to the log. Now, what is our target? What is the integer that we're changing? That would be this integer.
That's right.
What value are we setting it to? Well, again, you have the option of setting this internally in the node, or you can right-click, create a new variable, and set this to 5. So what we're doing is we're setting this variable to 5. To me, that's almost confusing. If it were me, I'd probably just set this inside the node and leave it at that.
Sure, we'll go ahead and remove it and show them once just hard-coding it in.
We'll go ahead and just hard-code this.
There you go.
So there we go. So now let's give this one more test. Right-click and play from here. And boom, you've activated the timed light switch. 5, 4, 3, 2, 1. Boom, lights go out. Now let's hit it again. You've activated the timed light switch. 5, 4, 3, 2, 1.
You're way off on the counting. There we go.
Oh, yeah, your audio is not off. That's just me. All right, so that is going to wrap up everything I wanted to show in this particular video. Now, that doesn't necessarily mean we're done. We still have some issues.
That's right. Yeah, well, we still got to restart the system.
Sure, I'd like to restart the system so the lights automatically come back on. Not to mention, right now, I can hit the E key and start this, and we can wait for it to get to about 3 and hit it again. And we start getting all sorts of weird messages. Because what we're doing is every time we hit the key, we're resetting this to 5. So you can see, you can really mess with the thing.
So, yeah, that's pretty much it.
Yep.
So that's going to wrap up this video here. Thanks a lot.